What is the pressure in a gas cylinder as measured by a manometer if the atmospheric pressure is 765 torr and the mercury level on the manometer's cylinder side is 5 inches lower than the mercury level on the atmosphere side? And the answer is D, 892 millimeters of mercury. So how did we get to 892, and what is a manometer? You can see in the diagram here a manometer which is hooked up to a gas cylinder. A manometer is a U-shaped tube that's filled with liquid mercury, and it's open on one side to the atmosphere, and on the other side it's hooked up to a tank of gas, or in this case a gas cylinder. And usually the purpose is to measure the pressure of the gas inside the cylinder. So what's going on here is the air in the atmosphere is in contact with this part of the mercury, and the gas inside the cylinder is in contact with that liquid mercury surface. If the gas pressure matches the atmospheric pressure, then it's pressing down on this side the same as it's pressing down on that side, and the liquid levels would be equal. But if the gas has a greater pressure than the atmosphere, then it would be pressing down harder on the gas cylinder side than it would be on the atmospheric side. And that's the case here. The liquid level is lower on the gas cylinder side, 5 inches lower, and that means that the gas has a pressure equal to whatever the atmosphere is, plus that additional 5 inches of mercury. So how many millimeters of mercury increase is equal to that 5 inches of mercury increase? We can convert inches of mercury to millimeters of mercury. You take your 5 inches of mercury, convert it to centimeters. 1 inch is 2.54 centimeters, and 1 centimeter is 10 millimeters. You can see the units canceling to give you millimeters of mercury, and the numbers calculate to give you 127. Might be tough to get that 127 without a calculator, but we can estimate it pretty well. If you take the 5 and multiply it by 2.5, when close to 2.54, that would give you 12.5. And 12.5 times 10 would be 125. So you can estimate the pressure increase over the atmosphere as about 125 millimeters of mercury. And so the pressure of the gas would be equal to the atmospheric pressure, 765, plus the 125 increase. And that would come out to 890. And if you do it more precisely, as is done here, the 765 plus the 127, that's what gives you 892. So you probably shouldn't be too worried about getting exactly 127, because if you just do the estimate and you come out with 890, you can see from the choices here that there's only one possible choice, which is close to the 890. That's D.